Guys, our plan here is to look at these parabola equations and graph them on a calculator. You guys know to graph them on the calculator, they have to be y equals, right? It can't just be any old form. Okay, that's in my opinion, the main downfall of graphing on the calculator is it has to be y equals. And they're not always easy to get to y equals, although some of these aren't as bad as you might think. So, as we look at A, thoughts on how to get this y equals. So we want to solve for y. Okay. So right there, since it's y minus 4 raised to the power of 2, ask yourself, how do we get rid of that power of 2? There's two options. The good option is to take the square root. Yes, we could talk about FOILing it out, but that's not going to be the good option. Okay? So the good option is going to be take the square root. If we take the square root of one side, you take the square root of the other side. What's the square root of y minus 4 squared? Y minus 4. What's the square root of 8 times 20 x minus 3?
Square root, or plus or minus square root of 8.
Oh. So general first answer, the square root of 8 times x minus 3 is going to be the square root of 8 times x minus 3. Okay, guys, we just took the square root in an equation setting. When you take the square root in an equation setting, what do we have to include? A plus or minus. And you would figure that out real quickly because when you go to graph this, you would only get half of a parabola if you didn't put the plus or minus. Okay? Am I done? Have I solved for y? Yeah, if it's y minus 4, we're going to add 4. Where you add the 4 is up to you. Okay? It's outside the radical, obviously. You can, what I like to do, you guys know, I like to put my plus or minus in between two things. It just makes sense to me. So when I write this, I'm going to write this as y equals 4 plus or minus the square root of 8 times x minus 3. The other option is you could say y equals plus or minus the square root of 8 times x minus 3, and then after the radical put a plus 4. They graph the same. Okay? Have we solved for y? We certainly have, yes? Okay. So let's try it on the calculator. See if it makes a parabola, yes? Okay. Are you figuring this out? What's the catch? Yeah, we don't have a plus or minus sign option, do we? So what's plan B if we don't have a plus or minus sign option?
You take the plus.
Yeah. We're going to do 4 plus the square root of 8 parentheses x minus 3. And then we're going to have to do in y2 4 minus the square root of 8 parentheses x minus 3. Okay, so it's obviously going to be 2 halves. And this is where I said if you forgot the plus or minus, you would only get one of these halves. Okay, I don't remember exactly what I need here, so I'm just going to do a zoom 6. What do you think? Does that make a parabola? Yeah. Now, you will notice a little bit of graphing failure there. In that, what looks a little weird? My pieces of the parabola don't precisely connect. That doesn't mean we did something wrong. It's just the way the graphing calculator works. Okay? So that is legitimately true that, you know, it doesn't exactly look right. I can't remember if I want to zoom out. I don't know if I want to zoom out. That might take me too far. But notice right there, the farther I zoom out, does it look more together? Yeah. If you don't have quite as close a view, it does look more like what you would expect. Now, a couple of things, okay? So we graphed this on the calculator. Your proof to me that you graphed it is sketch a graph. Okay? I am going to put down here that we type this in as y equals 4 plus the square root of 8 times x minus 3, and y equals 4 minus the square root of 8 times x minus 3. That was y1 and y2. Okay. As I sketch this parabola, first of all, does it make sense that it's a sideways parabola opening to the right? How can we tell in this situation? If you go back to the original form, I have an x equals a y squared. X equals y squared, is that a sideways parabola? And it is, isn't it? Okay, so that's a good indicator that looks right. Now, you can kind of guesstimate on the screen, but you can also look at your original equation. Can you tell me where that vertex is of that parabola? Because obviously I want to graph in the right ballpark. What are you thinking? You can kind of trace over there if you want. And that kind of gets me in the ballpark too. It doesn't put me exactly there, but look, I'm at 3, 4 something. Look at this original problem. What do you see here? X minus a 3 and y minus a 4. What's that make sense for my vertex to be? That makes sense for my vertex to be at 3, 4, because there's an x minus 3 and there's a y minus 4. Okay, so not that this has to be precise, but those are good things to be able to tell. So I've got a parabola that starts at 3, 4, going to the right. Something like that. I think it's supposed to cross to around 5. You know, I'm not looking for anything fancy by any means. Okay, so looking for some details along the line though. Okay, questions here? Okay, shall we try example B then? X squared minus 7x plus 3y minus 2 equals 9. My goal is to solve for y. Thoughts on solving for y?
Get y on the other side.
Be a little more specific with what you mean.
So add the 9 and then subtract the 3y.
Okay, so you're going to end up with 3y by itself though, right? Okay, and we can do this one of a couple of different ways. I was actually going to do it opposite, just so I could keep my positive 3y. Not that it matters though. Okay, we get the same answer in the end in terms of graph and whatnot. But the only y term we have is 3y, yes? If you're trying to solve for y, you're going to get the 3y by itself, so we're going to somehow or another move everything away from it. Katie suggested subtracting the 3y over, subtracting the 9 back over, so you have 3y by itself on the right. I was going to do just the opposite. I was going to keep my positive 3y on the left and move the other 3 terms over. Again, they're both good. They'll just look a little different, but they're both good. Okay, so I was going to actually subtract x squared, add 7x, and add 2. Am I saying this is the best way to go? Not necessarily. So I'm subtracting x squared, adding 7x, and adding 2 over to the right. When I do that, 3y remains on the left for me. On the right, what's that clean up to me? Okay, good. Negative x squared plus 7x and plus 11, because we do have those like terms of 9 plus 2. And not that you have to add those, to be honest, when you punch it into the calculator, but good habits. And how do I solve for y? divide by 3. Now, if Katie stuck with her direction, she's dividing by -3. She has all the opposite signs of me, and that's fine. Now, y equals options here. What am I getting ready to do with this equation? Type it in the calculator. Am I trying to graph it by hand or anything like that? No. So in all honesty, does it have to be a perfectly neat form? No. I'm going to leave it like this. -x squared plus 7x plus 11 all divided by 3. Because here's my thing. Do any of those terms really divide nicely by 3? It would turn into 3 fractions. When I'm getting ready to enter this in the calculator, this is going to be the easier way to enter it. Okay? So, give it a try. I'm going to do one big fraction bar. Okay. Does your parabola look like mine? My parabola is opening down. Does that make sense to you? Here's 2 things. One, in my original problem, there was a single y and an x squared, right? That can be adjusted to be some type of y equals x squared, or when you put them on opposite sides, y equals -x squared. When we got here, what do we have? Y equals -x squared. So that makes sense that it is an upside down parabola. Yes. Hi. I do not until next period. I have them next period, and I have them during homework, but I don't have them right now. Okay. So they sent us here. And Christy called looking for them during this time yesterday, too. Yeah, and I figured what it was, but I don't have them right now. I'll have them next period, but. I wonder where they're at then. Yeah, I don't know. Tell Christy to send me out. Okay, did you try and sketch something here? What would be the one helpful option if we're trying to sketch this? It'd be helpful to know what? Where that vertex is, yes? Now, last problem, my equation kind of told me. Does this equation really tell me where the vertex is? I don't have an easy form to see it. How can I find my vertex, though? What is that? It's a maximum, isn't it? Could you also trace and get an idea? I'm not going to veto that, because do I need anything specific? I don't. Okay, so you could trace to get an idea that it is, I don't know, in the area of 7.5 or so. I can also do a max though. Okay, so remembering those calculator skills, left bound, right bound, and a guess. And then of course it gives me a decimal, but my max is 3.5, and then 31/4, which is 7 3/4. Okay. So that gives me an idea of where I'm going. And guys, I'm not looking for preciseness here, okay? I mean, ballpark, yes. Precise, no. So max around that area. Looks like I'm going to be crossing through over here. And somewhere over there. And that vertex is a little pointier than it should be, but again, I'm just looking for some kind of proof that you plugged it into your calculator and got it, got something working. Okay. 2 down, 1 to go. And so far you've seen 2 different solving types. We've got a third solving type here. So, take a peek at C. y squared minus 6x plus 2y plus 13 equals 0. Oh, and I guess I was 3.5, 7.75. I was going to label that and forgot. But okay. Thoughts on solving for C? Okay. Add 6x and subtract 13 to the right. What's that going to leave on the left? Y squared and 2y. Okay. My job is to solve for y, yes? So I'm going to leave, I want all my y's on one side, everything else on the other side. So I agree. I'm going to add 6x and subtract 13 over. So that means at that point, I have y squared plus 2y equals 6x minus 13. Okay. My job is to solve for y. That's eventually my goal. What's the issue? Yeah, we have two y variables and they're not the same, are they? They're not like terms that I could put them together. I've got a y squared and a 2y. Okay. There's a hint up top. Solve for y. You might have to complete the square to do this. This is your ideal situation. When you have a y squared and a y term, and your job is to solve for y, this is your ideal completing the square situation. I gave you a hint there also in that I left a gap. When I leave that gap, that's my hint that you're going to be completing the square. Okay? How do we complete the square? Wrong formula.
B over 2 squared.
Yeah, you're doing axis of symmetry. You're doing the other formula, right? The two formulas you guys always get confused. So completing the square is B over 2 quantity squared. What is my B value? My B value is 2, isn't it? So 2 divided by 2 quantity squared. 2 divided by 2 is 1. 1 squared is 1. What do I do with that 1?
Add it to 2y and subtract it.
Half right.
Wait, you add it to both sides, right?
Right. Okay, so here's the deal. We're going to add it to that 2y, that y squared plus 2y to complete the square. We're on two opposite sides of the equation. What you do to the left side of the equation, you have to do to the right side of the equation. So we are going to add 1 to the left, and that means we're going to add 1 to the right. Okay? When we do an add and a subtract is when we're working on the same side of the equation. Okay, so there is that existence also, not in this case. Okay, after you complete the square, you're adding that 1 on both sides. What do I do on the left? Your job is to factor. Does that sound familiar? And when it's going to factor into parentheses squared. It's going to be 2 parentheses, but they're going to be the same, right? What's the square root of y squared? Y. What's the square root of 1? 1. What's my middle sign? This is a plus 2y, so it's plus. You can also think of this as what multiplies to be 1 and adds to be 2. And that is 1 and 1, right? Okay. On the right side, we're just going to clean up. 6x minus 13 plus 1 becomes 6x minus 12.
Square root it.
Have we already done this part today now?
Yeah.
If it's y plus 1 quantity squared, your next step is to square root. So square root of y plus 1 squared is y plus 1. What's the square root of 6x minus 12? Plus or minus the square root of 6x minus 12. And how do I finish solving for y?
Subtract 1.
Yeah, if it's y plus 1, I'm going to subtract 1. So I end up with y equals -1 plus or minus the square root of 6x minus 12. And as far as I'm concerned, that's a great way to plug it into the calculator. What's the catch when you plug this one into the calculator?
Negative. It's big. Maybe that's just
No, you have to.
like it's the
-1 plus the square root of 6x minus 12 and -1 minus the square root of 6x minus 12. Oops. Now, there is a difference. I think this might be what Emma's referring to. There's a difference between a negative and a minus sign according to our calculator, right?
yes.
You will get an error fired back at you if you use a minus sign in front of the 1 there. Okay, it doesn't like that. Okay, it's showing a gap, isn't it? It's okay. Okay, it happens. Guesses on where that vertex is?
-1. And 2 negative.
2 -1? And it is. Now, I've got a way to show it to you here as well. If I rewrite this in factored form, I just want to show you this. 6x minus 12, what do you know about 6x minus 12? That's also 6 times x minus 2, isn't it? And I'm not saying you have to rewrite it like this by any means, but the claim just now was the vertex was at 2 -1. There's the 2, and there's the -1. Okay? So there is, there is a connection. Got my vertex there. Looks something like that. Okay. Every problem's a little different. You're going to have to work and look for the options there. But this is what you should be doing on those last 3 40s. 40, 42, 46. Okay? Yes?
I have a question on the homework.
Okay, let me stop this.